So we want minus k plus 9x squared plus 4x plus 2, and that's supposed to have one real root. So, if it has one real root, what's the discriminant supposed to be? Yeah, the discriminant has to be 0, which means b squared minus 4ac has to be 0, which means 4 squared minus 4ac has to be 0. 4ac, is that right? Yeah, I think that's right. Okay, so that means 16 plus 4k minus 30, oh sorry. I think what I'll do is I'll just multiply by the 2 first. So I'll make that 4 and 8. So I get 16 plus 8k minus 72 equals 0. So I get 8k equals 72 minus 16. What's that? 56, is it? Is it? Yeah? So then k will equal 56 over 8. What's that, 7? So k is 7 in this one. Yeah. Okay. No probs. Okie dokie. Did you write that down? So you said page 20, did you?
No, 26.
26, okay.
2G.
Right, 26 2G. Okay. Oh yeah, this one.
Yeah.
Okay. Let's do this one. Yeah. That's I said I would. What do we say? This is HS1 or 2?
2.
This is 2. 2 on a Wednesday. Yeah, okay. You can just borrow a pen there, please. You guys have a spare pen? Right, Michelle? Yeah. Mariam? She's in HS1. M-A-R-Y-A-M. Shapers. Alright. So I have her on the list here then. Abir? Okay. Autumn? Yeah. Celine? Sophia? Mubarak? Yeah. Chidera? Is that right? Are you sure? You're not just being nice to me. Okay. Mohammed?
Here.
Where's Mubarak?
Yeah.
Oh, there you are. Do you not feel the need to say anything when I
said yeah, and then you were like, yeah.
Alright. Sabrina? Yeah. Mosa? Ahmed?
Yes.
Safra?
Yes.
Angelina? Angela, sorry. Angela, yeah. So the only problem here is Mariam is supposed to be in HS1. Very strange. But other than that, everyone's here. Alright, so if we can look at page 26, 2G.
Is it because many lines pass through the origin?
Well, not just because it passes through the origin. It's kind of like that. So, page 26, 2G. So you have 5x plus 2y equals 0 minus 5x squared plus 8xy plus 4y squared equals 0. Okie dokie. The best way to do this one by factorizing, yeah. So what you do is you change this fella. Well, okay, it has to be 5 and 1. And one of them has to be a minus. We'll figure out in a moment. I need an 8, 2 and 2?
5 5x plus 2 and minus x plus 2y.
Oh, I left out my y, didn't I?
5x plus 2y.
You think the minus should be on the x?
Yeah.
Yeah, it should be, shouldn't it? Like this?
Plus 2y.
Yeah. Yeah? Now, this is kind of an interesting question because this equation here tells us absolutely nothing. Now that might be interesting. You might think, what is making me throw this equation away? Like, what makes it useless? Well, it's useless because of this. 5x plus 2y must be 0 because of the previous equation.
Yeah.
So there's absolutely nothing. There's nothing that this equation can tell me about x and y. Nothing. It's as if it's a bit like if I had something like this. If I said x plus y equals 2, and then 2x plus 4y equals 4, for example, yeah? This equation tells me nothing I didn't already know, from the previous one. Because I can see that this equation is really the same thing as what it was previously. So likewise, this equation tells me nothing that I didn't get from this equation. So in fact, I only have one equation. And the reason I have infinite answers is because there's infinite number of ways to solve just one equation. So for example, one answer could be, I don't know, like if x is 1, then y would have to be minus 2 over 5, for example. Or, if x was 2, then y would equal minus 5. Minus 10 of, did I do that wrong? Let me try that again. If x is 1, then y would be 5 over 2, minus 5 over 2. If x was 2, then that's y equals minus 10 over 2, minus 5. Yeah. If x is 3, then we'll get another value of y, and this thing goes on forever. It's because I have only one equation but two unknowns. And if you want to know exactly what's happening on the graph, what's happening is this. My first equation is in blue, which will be something like this, as an example. And my second equation, which is in red, I think is something like this. It looks like an X. So the red and the blue line overlap at infinitely many places. So I have infinite answers for x and y. So it's a little bit of a trick question because although it really looks like you actually have two equations, you actually only have one equation in that last one. So that's kind of a tricky one. It's kind of a tricky one. No. Okay. What's next now? 24, yeah. Which one?
First one.
Like, which letter?
A.
1A, yeah? Yeah, okay, I'll do 1A. No answer. Yeah. Yeah. Okay. Page 24, 1A. So you have y equals 9x cubed plus 10x squared minus 43x plus 24. I think x equals 1 could be a solution. Let's try this. Try x equals 1. So then you'll get 9 plus 10 minus 43 plus 24. So that's 19 and 20. Oh no, actually 24, 30, it's 43. Minus 43 plus 43. So therefore, x equals 1 is a root Therefore, x minus 1 is a factor, which means the remainder should be 0. Yeah? Because the remainder was 0, rather. Okay, so let's divide. X minus 1 gets divided into our cubic. 9x cubed plus 10x squared minus 43x plus 24. Yep. Okay, so the first one will be what? 9x squared. And so, multiply, we get 9x cubed minus 9x squared. And then a beer. Subtracting, what do I get? You're a beer? I know, it's alright. I'm only asking because she was asking me about this question. Are you happy with that 19x squared? Yeah. And then carry the other two down. Okay, what's next now? Anybody? So, what's the next one up here? 19x. So, 19x squared minus 19x, yeah. So what's that? Minus 24x plus 24. And finally, minus 24, leaving me with minus 24x plus 24. Right, now we have the job of having to factorize. We have one factor already. Let's get the other two, if they exist. Hopefully they do. I'm going to go with 3x, 6 and 4, you think? 12 and 18? No, I can't combine them to make 19. 12 and 2, 36 and 6? No, maybe it's not 3 and 3. It's 9. 8 and 3, like this?
Yeah.
That's 36. No. Oh, 27, sorry. 27 minus 8.
It's minus, yeah, and it's plus.
Yeah. So, we have 3 roots. 1. No, 9. I think it's 9x, yeah. Alright, okay. 1, 8 over 9, and minus 3 are my 3 roots. 1, 2, 3. And where does it cross the y-axis? It crosses the y-axis at 24 then.
X squared minus 3z. 6. The answer is 6.
Do you not have some pie charts to be making or something?
You don't eat my pie, do you?
Yes, yes. Alright. Quick sketch here. Can I scroll down? Yep. So let's see. 24y x. There's 1. There's 8 over 9. And there's minus 3. So I need to hit the 3 points. Let's see. So I think what's going to happen, it's going to go down like this, turn a little bit here, and go up. So that's what I'd say the graph would look like. Yeah. It's okay?
So
Yeah.
is like, is this positive like this, right?
I think this is right, isn't it? Wasn't it a positive?
Yeah, positive.
Yeah, up, down, up.
Negative is down, up, down.
Yeah. Yeah.
Can you do a regular zero question?
Which one's that now? What page? Which page? Just give me a page and a question. Yeah, Michelle? Same page, 2A, yeah? Yeah. Okay. Minus 5x cubed minus 24x squared minus 34. Same page. Now, Michelle, the first thing I think I'll do is I think I'll multiply everything by minus 1 because there's a minus in everything. Just so I can get rid of the minus, you know? It's a little easier, isn't it? So I get 5x cubed plus 24x squared plus 34x plus 21 is greater than 0. Because I multiplied by -1, I have to flip it around. Yeah? Right. Let me see. Let me try x equals -1. So what's that? -5 plus 24 minus 34 plus 21. That is 55 minus 439. And that's of course not 0. Okay. Minus what? -3, is it? So you get 5 times minus 125 plus 24 times 9 minus 34 times 3 plus 21. You're saying that's equal to 0. Yeah. I'll believe you. So therefore, x plus 3 is a factor. Okay, let's divide now. X plus 3 divided into 5x cubed plus 24x squared plus... No, they're all pluses now, aren't they? Yeah? Yeah. Okay, what's first here? It's 5x squared, isn't it? So that's 5x cubed plus 15x squared. 9x squared plus 34x plus 21. So that's plus 9x. 9x squared plus 27x. 7x plus 21 plus 7. 7x plus 21. Okay. That is 5x. X. No factors. No factors. Okay. So that means we have only one solution, is it? X equals -3. So let's draw what on earth this looks like. So you have here -3, and where does it cross the y-axis if I'm looking at this equation? Yeah, actually it's funny because I changed the signs. What I'll do is, I'll look at this one. Well, actually, which would you prefer, the top one or the second one? With the minuses? No. Yeah, I'm going to pretend that it didn't happen, so I start my question. Like, imagine you started here. You'll get the same answer. You'll get the same answer. There's always one student every year who doesn't believe me, but you'll get the same answer. See, right now you're thinking, no, you won't. I'm absolutely certain you won't.
No, like the first equation is negative and second is positive. So negative starts from here.
True, yeah.
And the positive starts.
Oh no, I know this. Yeah.
You
flip the graph, yeah? But you also flip the inequality.
So it's still right if you do
Yep. It doesn't matter which way you do it. You have a choice. I'm going to stick with positive. Oh, that's what I was trying not to do, but okay. I'll do both. So I'll do it this one. A. Okay? So it crosses at -3 and it crosses here at 21. It's more useful than having to mess with the minus, but anyways, we'll do both. So, what did I say? -3 and 21? Yeah, so maybe it looks something like this. It crosses the two. It doesn't matter too much. Now, I want it to be more than 0, right? So where's it more than 0? Here's more than 0. So it means x should be bigger than -3. Now, if I looked at the first way, if I drew it like that, well, I still have -3 and I still have 21, right? But because it starts with a negative, instead of going up, down, up, I must go down, up, down. Down, up, down. So,
No, it's -21.
is it? Oh, sorry, thank you. Should be -21. And I go, what did I say? Down, down, up, down. Like that. Yeah, but this time in B, I want it to be less than 0. So that's below. So that means x must be bigger than minus 3. So it's the same then.
Can you do page 28?
Yep. Now in a second.
In page 22,
22.
I don't know where I'm going wrong.
6.
6
Let's see. Yeah. Don't know now. Don't quite feel like doing that one. It's not something that's on the exam. No. I just put it in there to keep you busy. So,
You don't think we have enough work?
can never have too much maths. Nobody's ever died from having too much maths, so. No. Yeah, why don't you struggle with that a little bit more? Because it'll be good for you, overcome difficulties. And if you still haven't figured it out by next week, I can do it.
The thing is,
Number 6 on page 22.
I was trying to eliminate Q, I guess. Yeah. No, I just eliminated C instead of Q.
I don't think that should
I'm
matter.
getting the right thing.
You did get the right thing?
I checked it 3-4 times.
Okay.
For both things.
Okay, maybe I'll do that one next week then. Well, do you think it's a mistake in the answer?
No, I don't know. I don't know why I'm getting it wrong.
I'll tell you what. I'll just answer other questions first, because I should prioritise things which is definitely on the exam, and this is definitely not. So we'll just see what other questions people have. We can come back to that one later this morning if there's time. Okay, yes? The answer for which one? You think the answer's wrong? Maybe you can check her answer, because you said you did it and you got it. Yeah.
Eliminated B? You eliminated B? Or Q and D? No, did you eliminate B or Q?
Yeah, which one did you cancel first?
I factorized 16x.
Yeah, and you got your two equations of P and Q. Yeah.
And which one did you remove? P or Q?
Which one?
Q. Yeah. And those who are doing Q, who are doing Q are getting the answer. But
it shouldn't matter which one you do first.
I'm doing P.
Oh, no, this sounds suspicious. It shouldn't really matter which one you do first. So,
That's why I asked you.
I'm sure you're doing something wrong. You know what? I'll just check your notebook later and we'll see. Okay, what's next now? 28. Oh, and what? Okay, well, which one? 28. 3. Okay. Yeah. Page 28. What? Like 3A? Yeah? Yeah? N? Yeah. M. 3M. Okay. Minus 7 less than or equal to minus 2x plus 17 less than or equal to 7. So what I'll do, I'll minus 17 on everything. So that's minus 24 minus 2x minus 10. Yeah? Now, what should I divide by now? Divide by minus 2. So now I get 12, x, and 5. But I also tell you, what do I tell you? I tell you x is a natural number. Yeah? So what are the natural numbers between 5 and 12? 5, 6, 7, 8, 9, 10, 11, 12 is the answer.
have to list all the numbers on because all numbers in this function are on it because it's 5.1, 5.2.
Yeah.
So, using your unsigned, that form is not good enough. You have to basically list it out. You have to
Yeah.
say each number.
Yeah. But especially if I said x is a natural number.
But if you need to specify, we can split it that way.
Yeah.
Can you do Gaussian elimination?
Which page?
Page 6.
Oh, Gaussian. Okay. Which one?
C.
Okay. Does it affect your decision to ask me if I told you it's not on the exam? The Gaussian? No, it's not. Yeah. Yeah. It's funny, isn't it? So funny. Yeah.
So why are we learning this?
Because learning is never a bad thing. It can only be a good thing. Okay? You're never a worse person for knowing something. Right? Right? You never learn something and become a worse person for it. True? True? No, look, the thing about the Gaussian is it's not on the exam in the sense that they won't ever say solve it using Gaussian method. But you can certainly use that method if you want, and I do find it useful. I really find the Gaussian useful for when you have tree, x, y, z.
Would they give us x, y, z?
Not in semester 1, never. Now they might in semester 2. It's quite rare, but they might. But certainly not in semester 1. But anyways, I'll do it. Tree.
Can you do this X, Y, Z?
Okay. You want to beef it up a bit, so 2x plus 3y minus z equals 4. I'm just making one up here.
Can you make it
Fractions as well.
Yeah, so we can see the highest possible way to come.
Fine. Hold on. A half x plus a half y plus z equals 2. You see, I can't just, I have to be solving this in my head at the same time, so I have to pick something that actually has an answer. So,
you could use the fraction.
no, you can't actually, because you can't just pick random numbers because you might not get an answer. Because when you have 3 equations, there's no guarantee that they'll meet at one point. Only when there's 2. 3/4 x minus 1/4 y plus z equals 3/2. I really hope this has a solution. Is that okay? Yeah? Alright. Right, okay, so let's look at the Gaussian method for this. Alright, so first I'll change it into my block. 2, 3, minus 1, ... 4. A half, 1, 2. 3/4, minus 1/4, 1 and 3 halves.
Sorry, if they give us the x, y, z, they always give us 3 equations, or just they can use x, y, z with cheap equation?
Oh no, it has to be 3. Yeah. Okay. What should I do first? I think the first thing I'll do is I'll multiply this guy by 2 and multiply this guy by 4. No, actually, I think I can do even better than that. multiply this by 8, multiply by 12. Yeah. Oh, for goodness sake. Sorry. Multiply this by 6, this by minus 12, by minus 8. Now, why did I pick those numbers? Well, watch what happens now. So if I multiply the top one by 6, what do I get? 12, 18, minus 6, 4. Yeah? Then I multiply the next one by minus 12, what do I get? Minus 6? Minus 6? Oh, sorry. I said 6 here. Bad teacher. Should have said 3. Yeah, so I'm trying to get 12s. So I'm trying to get 6s. 6, 9, minus 3, 12. Minus 6, minus 6, minus 12, minus 24. Minus 6, 2, minus 8, 12, minus 12. Now, I'm really happy because I managed to get these two opposite to this guy. That's what I was trying to do. Yeah? So, what should I do next? I should do row 1 plus row 2 and put the answer on 2. So, 6, 9, minus 3, 12. 0, 3, minus 15, minus 12. Minus 6, 2, minus 8, minus 12. Okay, and now I should do row 1 plus row 3 and put the answer on row 3. So now I have 6, 9, minus 3, 12. 0, 3, minus 15, minus 12. 0, 11, minus 11, 0. Yeah? Correct, yeah, okay. Right. Not so bad, not so bad. Next, I'll multiply this by 11 and this by minus 3. So I have 6, 9, minus 3, 12. 0, 33, what's 15 times 11? Minus 165, is it? And minus 121?
Yeah.
No, it's not.
Yeah.
It's not. It's 144 minus 12, 136. So 136. And this is 165. Guys, why are you making me work so hard? You have calculators. Come on. 132.
Yeah.
Thank you. And 15 times 11?
165.
Thank you. Okay. 0, 33, minus 33, and 0. Oh, sorry. Minus 33 plus 33. Okay.
Why do you multiply by 11?
I'm making these two the same. Row 2 plus row 3, put the answer on 3. Okay. 6, 9, minus 3, 12. 0, 33, minus 165, minus 132. 0, 0, what's this? Minus 165 plus 33. Minus 132, minus 132. Yeah? Okay, I'm going to divide this line by minus 132. I'm going to divide this line by 3. Can you divide 132 by 33? You can. This divides by 33, doesn't it? Yeah? So, 2, 3, minus 1, 4. 0, 1, minus, what's that? 5. 4. 0, 0, 1, 1. Yeah? So I have it simplified.
Yeah, so Z is 1.
Yeah, so I have Z If I look at this one, I have z equals 1. And then if I look at this one, I have y minus 5z equals minus 4. And then if I look at this one, I get 2x plus 3y minus z equals 4. Now if z is equal to 1, I can put that in there and I get y is equal to 1. And if z and y are both equal to 1 and I put in that, I get 4 minus 5 is minus 1 minus z equals minus 1. So z equals 1 then. So my answer is, so x equals 1. So my answer is 1, 1, 1. The easiest one I could do in my head.
Is it the only method? Or so if you want only method to use for the 3?
No, you can use the elimination method. So you take two equations, eliminate z, take two equations, eliminate z. It's your two new equations, eliminate y, and now you have x. Yeah, so like imagine you have three equations, 1, 2, 3. From equation 1 and 2, eliminate z, and you'd be left with x and y. From equation 2 and 3, eliminate z, and you're left with x and y. From equation 4 and 5, eliminate y, and you'd be left with x.
We're basically doing the same.
We are, yeah, like I mean if you were to look at it, yeah. You're just taking out the trouble of having to write x and y. And you're doing something a little bit more interesting. A little bit more interesting by getting the triangles of zeros. Yeah.
But you don't use the substitution method.
You can use the substitution method. So, if you have equations 1, 2, and 3, you can make x the subject here, you make x the subject here. And if you put that into the third equation, you'll have an equation with x and z, and you realise, so it's not quite as easy to use substitutions. You have to think really carefully about how can I rearrange things so I have only one equation with one unknown. How would you do that? That's a bit tricky.
It's too much multiplication.
Huh?
It's too much stress.
No, it's not. What are you talking about? You're just multiplying numbers. Substitution is too much stress. Yeah. Yeah. 17? Yeah. It's funny actually, yeah, but you can follow the same pattern that I did. Row 1 plus row 2 to make the 0 on row 2, and then row 1 plus row 3 to make the 0 on row 3, and then row 2 plus row 3 onto 3 to make the third 0, and it actually is the same pattern. Yeah. Page 18. Which one? 18. No, that was the very first question I did. That's your tough. You can watch it. You can watch it on YouTube. Yeah. I did 3M. Yeah. What's next now?
What other things are there that is supposed to be done?
Page 28.
I don't know. 28. Yeah. Yeah. 5. Yeah. Does it affect your knowledge to ask me to know that this one's not an exam question? Yeah.
All the last questions.
No, don't do that as a rule. Don't do that as a rule. If you really, really must know, I can tell you right now. Yeah? Okay. Guys, if you really want to know which questions I just put in for fun, let's start with page 4. No, page 2. Okay, so the first thing is, on page 2, everything is an exam question. So if you want to put a tick there. Page 4, everything's an exam question. Page 6, questions 1 to 3 are exam questions. Page 8, everything's an exam question. Page 10, everything's an exam question. Page 12, everything's an exam question. Page 14, everything's an exam question. Page 16, only 1 to 3 really is an exam question. Page 18, it might be, but I'd have to look more carefully at the syllabus in past exams. I doubt it though.
Small.
Yeah. The questions deleted on page 16, the 4 and the 5. It's not really an exam question. 18 is everything. Now, 20, it could be everything. However, I haven't, 5 could be on the exam, but I haven't seen them ask it yet. But I would still say it is everything on page 20. Page 22, it's 1 to 5. Page 24 is everything. Page 26, it could be 1 and 2. However, they've not asked a question like number 2 yet. But I don't see a reason why they shouldn't or couldn't. So, it is 1 and 2. 28, they've only asked questions like 1 to 4. And page 30 is, it could be anything, but it's really just question 4. On page 30, it's only question 4, really, is what they ask in the exam. So, your rule of deleting the last question is mostly wrong. It's just on a couple of pages, the last question is a little bit harder than what you would get on the exam. That doesn't mean don't do it. That just means don't worry if you can't do it. You should be happy if you can do it. Just don't worry if you can't do it. Yeah? Don't know if you're angry at me for giving you these. Is that okay now? So you have a better picture of what the exam difficulty is. But like I said, I'd like you working a little bit harder than the exam, so it makes the exam feel easier. That's the reason I put a couple of questions in that are more difficult than you need. Okay? But I can do it next time if you really, really want me to. Okay. We'll wrap it up there, so. Yeah? Okay. What class have you got now? Chemistry, okay.